So here we have parametric equations. That means you have x in terms of t and y in terms of t, but you don't have x in terms of y. But the question is to find dy by dx. So the only way to find dy by dx is to use the chain rule. Now, the chain rule means that we can find dy by dt and then divide it by dx by dt. So dy by dt we can find from here, and dx by dt we can find from here. Now, first of all, let me remind you that the derivative of tan theta, or tan, let's say d by dx of tan x is secant squared x. So you need to know that. And the derivative of sine x is cosine x. You need to know that. So we can then find dy by dt by taking the derivative of that. So that will give you 2 secant squared t. So there's no x here, we're using t. And the derivative of sine squared, again we have to use chain rule. So because it's squared, it becomes 2 times sine t, but then we need to multiply by the derivative of sine, which is cosine. We just said that there. So cosine t. So it says dy by dx, so we need to divide. So we can say dy by dx equals 2 secant squared t divided by, that's this, 2 sine t cosine t. And the 2 will cancel with the 2. And I guess the cosine in the denominator, you can replace it with secant. So it's secant cubed t over sine t. So I've just taken 1 over cosine and I've called it secant. So that's the final answer for part A, using the chain rule.